In this video, I am going to discuss about triple product of vectors and quadruple product of vectors. So let's start the video with scalar triple product. Scalar triple product of any three vectors, vector A, vector B and vector C is defined as vector A dot vector B cross vector C, or vector C dot vector A cross vector B, or vector B dot vector C cross vector A. That means the cross product of two vectors and dot of this cross product with the third vector. So it is also written as vector A, vector B and vector C inside a square bracket. The value of all three scalar products are same as long as cyclic order of vectors is maintained. The position of dot and cross signs can be interchanged without affecting the scalar triple product's numerical value. If vector A equals axi cap plus ayj cap plus azk cap and vector B equals bxi cap plus byj cap plus bzk cap and vector C equals cxi cap plus cyj cap plus czk cap, the scalar triple product of these three vectors is obtained as vector A cross vector B dot vector C, which is evaluated as first we evaluate the cross product of vector A and vector B, and then we dot this cross product with the third vector, vector C. So we get the expression after the cross product of first vector 0 plus ax by k cap minus ax bz j cap minus ay bx k cap plus 0 plus ay bz I cap plus az bx j cap minus az by I cap plus 0. And if we dot product this vector with the third vector cx I cap plus cy j cap plus cz k cap, we obtain the expression cx multiplied by ay bz minus az by plus cy multiplied by az bx minus ax bz plus cz multiplied by ax by minus ay bx. This expression can also be transformed into 3 by 3 determinant form. So we get the expression inside 3 by 3 determinant ax ay az in first row and bx by bz in second row and cx cy cz in third row. The value of above determinant will not change if we give twice row exchange, and the determinant will take form of cx cy cz ax ay az bx by bz and bx by bz cx cy cz ax ay az. All three determinants had same value and are equal, which proves that scalar triple product will not change if we do not change the cyclic order of vectors. Now let's discuss the geometrical interpretation of scalar triple product. Scalar triple product shows the 6 times volume of tetrahedron. So if we draw a tetrahedron whose concurrent edges are vector A, vector B and vector C, the volume of tetrahedron is obtained as 1 by 6th of the scalar product of vector A, vector B and vector C. Now let's discuss the volume of one more solid geometry, which is the parallelopiped. So using the scalar triple product, we can find the volume of a parallelopiped whose coterminous edges are represented by the vectors vector A, vector B, vector C. So the volume of parallelopiped shown in the figure can be evaluated as the scalar triple product of vector A, vector B and vector C. Now let's discuss about the vector triple product. Vector triple product of three vectors is vector A cross vector B cross vector C. and this vector triple product for the three vectors a, b and c is evaluated by evaluating first the cross product of vector a and vector b, and we can also find the cross product of vector b and vector c in the first step, but here I am just finding the cross product of vector a and vector b. So the cross product of vector a and vector b can be obtained in a 3 by 3 determinant form, whose first row is I cap j cap k cap, second row is ax ay az, third row is bx by bz. So the obtained value of vector a cross vector b is taken as the first vector, and then we find its cross product with vector c. So uh, we can also find the cross product by considering a cross b as first vector and vector c as second vector. So if we do so, we can use this formula of finding the cross product of two vectors. So using this formula, we just write the first row as I cap j cap k cap, and the second row will be the x, y and z component of vector a cross b. So the x component of vector a cross b is ay bz minus az by, y component is az bx minus ax bz, and z component is ax by minus ay bx. And the third vector, which is the second vector of cross product, is the cx cy cz as its component along x, y and z direction is written in the third row. So now let's discuss the geometrical interpretation of vector triple product. So the vector triple product of any three vectors, vector a, vector b and vector c, is a vector in the plane containing vector b and vector c. So the formula of vector triple product is also obtained as the triple product equals vector a dot vector c times vector b minus vector a dot vector b times vector c. The scalar quadruple product. Scalar quadruple product of four vectors, vector a, vector b, vector c and vector d, is written as vector a cross vector b dot vector c cross vector d, and its formula is obtained as vector a dot vector c times vector b dot vector d minus vector a dot vector d times vector b dot vector c. It can be written in determinant form using 2 by 2 determinant, whose first row is vector a dot vector c and vector a dot vector d, and second row is vector b dot vector c and vector b dot vector d. So now let's discuss vector quadruple product. Vector quadruple product of four vectors, vector a, vector b, vector c and vector d, is written as vector a cross vector b cross vector c cross vector d, and this is obtained as the expression the scalar triple product of vector a, vector c, vector d times vector b minus scalar triple product of vector b, vector c, vector d times vector a. So this is also a standard formula, and the geometrical interpretation of vector quadruple product is a vector parallel to the line of intersection of plane containing vector a and vector b and plane containing vector c and vector d. And with this discussion, the discussion on the vector triple product and vector quadruple product is concluded, and with this I am ending this video. Thank you for watching this video.